We're going to dive deeper into conditional statements in this section. Let me start with three things that we'll look at. The first is the converse. Before I start, I should say this. Let P imply Q. Then we'll start with the converse. Converse of that statement is Q implies P. Then we have the inverse. So the negation of P implies the negation of Q is the inverse. And then finally, one I mentioned before, the contrapositive. That's squiggle Q implies squiggle P. Let's do an example. Consider the statement "If you lead, then I will follow." So here, let me indicate what I'm using for a P. That would be you lead. And then I will follow will be my Q. So the statement right now is of the form P implies Q. So let's go ahead and get our converse. The converse is Q implies P. So what will it look for us? If I will follow, then you will lead. Inverse. This is where we negate the antecedent and the consequent. So now I am going to negate if you lead. So if you don't lead, then I will not follow. And then finally, the contrapositive. That's the negation of Q implies the negation of P. And so now I'll put my Q first, but I'll negate it. So I'll put if I will not follow, then you will not lead. Determine the inverse, converse, and contrapositive of "A rolling stone gathers no moss." All right, let's start with the inverse. This is not P implies not Q. Before I do anything, I should probably put the statement in Q, or if P, then Q form. So the phrase that I might use is this: if a stone is rolling, then it gathers no moss. So here, the P statement is a stone is rolling. So this will say, if a stone is not rolling, then it gathers moss. We also had to do the negation of Q as well. Let's do the converse. Here we just switched the roles. Q implies P. So now we would have it gathers no moss has to come first. So we'd say if a stone gathers no moss, then it is rolling. Or then it rolls, whatever. There's some flexibility there. And finally, the contrapositive. Here we're going to negate Q and we're going to imply a negation of P. So it gathers no moss was the original statement for Q. So then we'll put if a stone gathers moss, then it is not rolling. Let me put a summary up. So for P to Q, or P implies Q, we have the converse. That's Q implies P. We have the inverse, which is not P implies not Q. And then the contrapositive. This is not Q implies not P. I'm going to give you a series of statements, and I want you to find the converse, inverse, and contrapositive. So for each of the following, statements, write A, converse, B, the inverse, C, the contrapositive. Really, what I want you to think of when you see P implies Q is I want you to think of as P and Q are like variables. So I'll show you what are the ones we're going to try. So the first one we're going to try is squiggle P implies Q. So remember, if our statement starts off P implies Q, the converse is going to be Q implies P. The inverse is not P implies not Q. And finally, the contrapositive is not Q implies not P. So I'm trying to figure out where things are in relation to being first or second. So take a look here. The converse says, when you look at this, it basically says just switch them. Switch the Q and P. So switch whatever comes before and whatever comes after the implication arrow. So the converse for this first one then is simply where I switch them. Q implies not P. Now for the inverse, here I negate the thing that comes before and I negate the thing that comes after the implication arrow. So I'll negate the thing before, so I'll negate something that is already negated. implication arrow, negate the second thing. And then all you got to do is simplify it. Those two negations simplify to a simple P implies squiggle Q. So all of them are going to do stuff like this. And then finally, for the contrapositive, what I do now is I negate the consequent and put it in front of the implication arrow. So I'll negate the consequent. And then after the implication arrow, I negate the antecedent. So I negate squiggle P. Of course, this equals the negation of Q implies P. So that's the game that we're going to be doing. Let's start with another one. Let's start with, well, hey, I'll start with the contrapositive and see what happens when I start to do these things to it. So let's start with the converse. The converse, all I do with the converse is swap what comes before and after the implication arrow. So for this one then, I'll have squiggle P implies squiggle Q. Now for the inverse, you leave everything where they're at, but then you take their negations. So you leave everything alone, squiggle Q implies squiggle P, but you negate each of them first. And so those simplify to be Q implies P. And then finally, the contrapositive. This is where you switch the order of them. So now I'm going to have squiggle P implies squiggle Q, but you also negate. And of course, this just equals P implies Q. Let's try one more. Here, I'm going to start with something that looks awful. R and squiggle P implies P. Let's start with the converse. All you do on the converse is switch what comes before and after the implication arrow. So the stuff that came after the implication arrow was a P, and the stuff that came before the implication arrow was this R and squiggle P. So there's my converse. Now my inverse, I leave everything where it's at, but I have to take negations. So I'll have the negation of P, and I'll have the negation of R and squiggle P. If you were to leave your answer like that, chances are you would not find the answer in the back of the book, should you look. They expect you to use De Morgan's laws to rewrite this piece here on the left. This guy right here, if you'll remember, this is equal to squiggle R or squiggle P. That, of course, implies squiggle P. And then one last step in simplifying, I'll have squiggle R or P implies squiggle P. And the contrapositive. For that, we switch the order of them, so P comes first this time, and then the other thing comes last, except we take the negation of each. And once again, there's no simplifying that you can do to the squiggle P, so I'll leave it alone. But the other side, I can use De Morgan's laws again and get squiggle R or squiggle P, which is the same as squiggle P implies squiggle R or P. In order to facilitate this, we're going to need some more practice with if-then statements. So I want to do a few examples where I convert statements to if-then form. So convert each statement to if-then form. This is a leap year implies that next year is not. So for the if-then form, then, we can say if this is a leap year, then next year is not. Let me call that A, because I'm going to do several examples. B, surgery is necessary to correct an overbite. Surgery So what would we do for this one? Let's say if I have an overbite, or if you want to correct an overbite. Let's do that one. If you want to correct an overbite, you'll need surgery. An integer whose units digit is 0, 5 is divisible by 5. So now we're going to start with an integer. So we'll start with an integer whose last digit, or whose units digit, is a 0 or 5. So if the units digit in an integer is 0 or 5, then it is divisible by 5. And now a way of bolstering what we can do with these things, but at the same time complicating things, is the notion of biconditionals. So what we have is a new notation. We have arrows pointing in both directions. This is P implies Q, but it also includes Q implies P. So it's P implies Q and Q implies P. We usually say P if and only if Q. Or a shorthand for even that is P I F F Q. That's about as short as you can get for a notation. Now when we do the truth table, we have to work them separately. So true, true, false, false, true, false, true, false. So I'm going to do P implies Q first. We know that that's true in every spot except where we have true implies false. Now if you reverse it, now we go Q implies P. So now think of the implications the other direction now. So now you're starting with these and you're implying those. So true implies true is still true, but the next one, false implies something is obviously true. False implies something is true. The only one that's not going to be true is this guy right here. True implies false is false. So now if I want the whole thing, P, if and only if, Q, I want to make sure that we use the P implies Q and Q implies P. That's the version I would like to use. So here then, since we're having an AND situation, the only places where we have a truth value for an AND is when both arguments are true. So we have true and true gives me true. But the next one, false and true, and then true and false, both of these next ones will be false. And finally, true. What this means is that P implies Q and backwards, or P if and only if Q, only happens in those places where P and Q agree. Do you see I had a true across from where they were both true or where they were both false? It's in the areas where they disagree that the P if and only if Q is false. If I have P if and only if Q, this is the same that P and Q are logically equivalent. Let me show you an interesting implication that you may not realize is true. Let me call it an example. Believe it or not, P implies Q is logically equivalent to its contrapositive. Let me prove that. So we'll do the usual true, true, false, false, true, false, true, false. Then P implies Q. We've done this enough. True, false, true, true. Let me do not Q. So that'll be false, true, false, true. Not P. That will be false, false, true, true. And then not Q implies not P. Let me get my cursor back here, if I can find it. Here it is. All right, so I'm starting with this column and I'm getting to this column. So whenever you have falses in the first column, you know you're going to have true. So I'll do that immediately. Now true, false would give me a false here. True, true gives me a true here. So take a look at here. P implies Q. And here. You can see that they are the same. So they are logically equivalent. Another example. Squiggle P implies squiggle Q. So this is the inverse. Right? This is logically equivalent to Q implies P. Let's try that one out. P, Q. So I need to show that they have the same truth values everywhere in the table. True, true, false, false. True, false, true, false. Let me get my squiggle P's. False, false, true, true. My squiggle Q's. False, true, false, true. And now my implication. Squiggle P implies squiggle Q. So once again, I'll follow here. Anything that starts with a false will be true here. Here, that'll be false in that instance. And then true, true will be true. All right, let me go ahead then and do Q implies P. So now you have to kind of go backwards here. So I'm starting with this Q column, and I'm implying the P column. So we know that true implies true is true. We know that false implies anything is true. But true implies false is false. And finally, false implies anything is true. Now let's compare our two columns. Here's this column here. Here's this column here. And you can see in every instance, they have the same truth values. Therefore, they're logically equivalent. Oh, I think I forgot to mention, this other side was the converse. So the original statement is equivalent to the contrapositive, and the inverse statement is equivalent to the converse. So the original statement I'm not going to put that. I'll tell you what. Let's put P implies Q. So P implies Q is equivalent to not Q implies not P. So the original statement is equivalent to its contrapositive. So the original statement is equivalent to the contrapositive. And then the inverse was equivalent to the converse.